So using the quadratic formula, again, we just need to make sure that we have our A, B, C coefficients, and we can apply the quadratic formula. Again, the quadratic formula looks like this. X, where the graph crosses the zeros, that's going to be equal to negative b plus minus square root of b squared minus 4ac all over 2a. Okay, so there's our quadratic formula. Again, I want you to recognize that there is the middle. Okay, so that represents a vertex. So the middle plus minus this amount. This piece here actually has a name. It's called the discriminant. Okay, so this is our middle, and then we're going to go symmetrically plus and minus the same amount from the middle. And that's going to give us our zeros, or the solutions to the quadratic equations. So we just need to apply the quadratic formula here. So we're going to say x is equal to negative of negative 7 plus minus negative 7 squared. Make sure that we put that in brackets. Minus 4 times a times c. And that's all over 2 times a. Okay, so working that out, we get 7 plus minus square root of 49 minus 16 all over 2. And we can simplify that radical to, or this expression, to square root 33 all over 2. Okay, so there's our solution. So it looks like the center will be at 3 over 2. Okay, or sorry, 3.5, or 7 over 2. And we can, that's where our vertex is, and our zeros are going to be symmetrically distributed about the vertex. Okay, so again, same thing here. We want to apply the quadratic formula. It's going to be negative of negative 2 plus minus square root of negative 2 squared minus 4 times a times c. Make sure that we get all our signs and everything correct. Okay, so it becomes over 2 times a. So simplifying this then becomes 2 plus minus the square root of 4 minus negative, so it's going to be plus 4 times 3 times 5 is 60 all over 6. This simplifies to 2 plus minus square root 64, which is a perfect square. So then we end up with 2 plus minus 8 all over 6, so we end up with 10 over 6. Okay, so our solutions are going to be 10 over 6, which ends up being reducing to 5 over 3. Okay, and it's going to be negative 6 over 6, or negative 1. Okay, so just clean that up a bit. 5 over 3 and negative 1. So this happens to be factorable. So if we get rational solutions like this, that means that this was a factorable quadratic. Okay, before we can use a quadratic formula, again, we need to make sure it's equal. First of all, get rid of the fraction by multiplying by the lowest common denominator. And then I want to make this equal to 0. So multiplying this, I end up with x. X minus 1's cancel out. Okay, plus 3 times, nothing cancels here, so x minus 1, x plus 5. And here the x plus 5's cancel out, so we just end up with x minus 1. Okay, so we need to expand and combine like terms. Okay, so then we end up with x squared plus 5x plus 3x squared plus 12x minus 15 equals x minus 1. Okay, actually I'm going to move this over, so I'm going to make this negative x plus 1. Okay, then combining like terms, I end up with 4x squared combine all our x terms. We end up with 17 minus 1, so plus 16x. Okay, our constant terms are going to add up to negative 14, and that's equal to 0. Okay, so at this point, I could just plug these numbers in, but since this is an equation, and these are all even terms, I can actually get rid of one of the factors. Okay, and I can get rid of the factor of 2 here. So I'm going to divide that. I'm going to divide this by 2. So I end up with 2x squared plus 8x minus 7 equals 0. Now, whether I do this or not doesn't make any difference to the solution. Only thing this does is makes the numbers smaller or easier to work with. And again, the reason why I can do this is because this is an equation. I can divide both sides by the common factor of 2. Okay, and then I can plug into the quadratic formula. X is equal to negative 8 plus minus square root of 8 squared minus 4 times a times c all over 2 times 2. Okay, and then simplifying that, looks like it's going to be 64 plus 56. So it looks like square root 110. Just double checking that. Yeah, so that's going to be plus 56 all over 4. Okay, so then we're going to end up with, it looks like there's no common factor or perfect square factor that we can take out of there. So it looks like that is our final solution.